Okay, finite math students, I'm doing another video for you guys. This is going to be the last video until, let's say, next week, okay? Because I'm getting all videoed out. I have two other classes, and it seems like every day I'm just preparing videos for students. So I will do a video next week, um, but this is going to be the last video for a while. So this is October 21st. So, sometime next week I will do another tutorial video for you guys and upload it to YouTube. So for this video, I'd like to work on, let's say, 3 problems. Okay, maybe 4 problems, but I think that's really going to be enough. Let's look at your current homework assignment, matrices and linear optimization. Okay, it says here, I'm looking at problem number 125. The corner points for the bounded feasible region determined by the system of inequalities shown below are point O is at the origin, so x is equal to 0 and y is equal to 0. Point A, x is 0, y is 9. Point B, x is 3, y is 8. And point C, x is 7, y is 0. And these are the inequalities. They found the corner points for us, so it's not really necessary for us to graph this and find the corner points. The objective function p is equal to ax plus by, and the coefficients a and b are known to be greater than 0. Determine conditions on a and b that will ensure that the maximum value of p occurs at both points a and b. Okay, so for this one, we're basically going to have to make a corner point table. So let's see. Okay. So here is x, y, and this is going to be p. Excuse me. So let's look at the origin first. If x is 0 and y is 0, then I'm going to have a times 0 plus b times 0. And guess what that is? That's simply going to be 0. Okay, let's look at the next corner point. Excuse me. So for point A, I have x is 0, y is 9, and then I'm simply going to have a times 0 plus 9 times y. Okay? And now I'm moving on to corner point B, where x is 3 and y is 8. So here I'm going to have 3a plus 8b. And then finally for C, I have x is equal to 7, and I'm going to have y is equal to 0. So this is simply going to be 7a. Okay? Now I know from the problem it says here that the maximum value of p occurs at both a and b. Okay, so these have to be equal. Okay, the maximum value, if p is equal to ax plus by, and we know that a and b are greater than 0, determine conditions on a and b that will ensure that the maximum value of p occurs at both points a and b. So this is a and b, which means that, this should be a b right over here. That should be a B. Not 9y. That should be 9 times b. There we go. Much better. Okay, so therefore I have 3a plus 8b is equal to 9b. And I know that because it says here that the maximum value occurs at both points A and B, which means that 3a plus 8b must be equal to 9b. Let's simplify this equation. Minus 8b minus 8b. So then I have 3a is equal to b. 3a must be equal to b, or you could say if you divide both sides by 3, you'll have b is equal to, if you divide both sides by 3, then you'll have a is equal to b divided by 3. So you'll have 3a is equal to b, and if you divide both sides by 3, you're going to have a is equal to b divided by 3. Okay, so let's see. It looks like this should be the answer. B is equal to 3a. And that's correct. So it was just a little bit of algebra. I realize, some of these problems get challenging, but they're really not that terrible. And remember, if you really have a hard time with these problems, what do? You simply click on help me solve this, and then you do the problem again with different numbers, or view an example, or click on textbook. If you're really stuck and just can't figure it out at all, you can always email me, ask my instructor, but that should be a last resort. Because, guys, this is an asynchronous online course, which simply means you are really responsible for learning a lot of the material on your own. I can guide you to some degree. I can provide you with some guidance. I can answer emails. I can answer questions. I can upload tutorial videos, tutorial lectures, but really and truly, at the end of the day, you are responsible for learning this material. And that's simply the nature of this course. Unfortunately, if we never had to worry about this stupid pandemic, we would be meeting face-to-face twice a week, and it would probably be easier for you to absorb the material. But even then, not necessarily. I remember I taught this course in fall of 2019. And, if students don't show up to the lectures, if they come in a half hour late, an hour late, if they don't do the homework, if they don't read the textbook, if they don't ask me questions, they're still not going to learn the material anyway. So I realize online courses sometimes make it easier for students to goof off, but students can still goof off if they take traditional classes and they're not really, investing their time and their effort and their energy in learning the material. I think it's easier to fall behind. It's easier to be a slacker when you have an online course. But you can still do that even if you are dealing with face-to-face in-class instruction. So the bottom line is you really have to take charge. You have to take charge. You have to take responsibility for your own education. You have to read the book. You have to go through the problems. This is your responsibility. Ultimately, it really is your responsibility. And if you're not emailing me, if you're not asking me for help, and if you're not reading the book, and if you're not doing the problems, ultimately this is really your fault. Okay, so it's important for students to understand that. Okay, let's do another another example. Let me clear this up. This time I'd like to do a word problem, a story problem, because those can be very difficult for students, but they're also very important. Okay, let's look at problem. I think problem 130 deals with money. We all love money, right? We all love word problems that involve money. Okay. Oh, excuse me, a little bit of a yawn there. An investor has $60,000 to invest in a CD and a mutual fund. The CD yields 7% and the mutual fund yields 6%. The mutual fund requires a minimum investment of $9,000, and the investor requires that at least twice as much should be invested in CDs as in the mutual fund. How much should be invested in CDs and how much in the mutual fund to maximize the return? What is the maximum return? Okay, so first off, well, let me squeeze this down a little bit. Okay, so my objective function is profit, or P, profit is equal to, let's see, 7%, 7% on the CD, okay, and then 6% on the mutual fund. Oh. Okay, that's not terrific drawing here. I'm trying to squeeze this in as best I can. Okay, so the profit is going to be 7% on the CD and 6% on the mutual fund. And we know, of course, that the amount of money that you invest in the CD and the amount of money that you invest in the mutual fund, that has got to be greater than or equal to 0. Okay. And we also know, let's see. What else do we know here? We know that the mutual fund requires a minimum investment of $9,000. So actually the mutual fund, not only is it greater than or equal to 0, it has to be greater than or equal to $9,000. I'm drawing with my finger and my trackpad, so it's a little tricky to get this right. I usually write a little better than this. And we also know that the investor requires that at least twice as much should be invested in CDs as in the mutual fund. So the amount of money I invest in CDs must be greater than or equal to twice the amount of money invested in mutual funds. Okay. Let's see, and the investor requires that at least twice as much should be invested in CDs as in the mutual fund. So yeah, the amount of money in the CDs must be greater than or equal to twice the amount of money in the mutual funds. And of course, this is really important. If you add up the amount of money invested in the CD and you add up the amount of money invested in the mutual fund, that's going to have to be less than or equal to $60,000. I'm just going to write 60K. Okay. Okay, my dog's gonna start barking like crazy, so let's try to ignore that. Okay, so now we need, we need to graph these inequalities. We need to graph these inequalities. Okay. So here, let me see. We need to decide which is going to be x and which is going to be y, and that's really kind of arbitrary. So what I'm going to do, I'm going to say CDs, this will be x. I'm going to graph this along the x-axis and mutual funds along the y-axis. It really doesn't make much of a difference. This is kind of a personal preference. So I'm going to make a note to myself here. Why is that so big? Hold on a second. That is way too big. There we go. That's a lot better. Okay. So CDs will be plotted along the x-axis, and, well, I should say, okay, the amount of money invested in CDs will be plotted along the x-axis, and the amount of money invested in the mutual fund will be plotted along the y-axis. Okay, the amount of money invested in CDs will be plotted along the x-axis, and the amount of money invested in the mutual fund will be plotted along the y-axis. But again, that's an arbitrary choice. You could do it the reverse way and you'll still get the right answer. Okay, so it's really not a big deal. Let's see. Let's do a region plot first. Well, actually, we can just plot the lines. We can plot the lines. Although maybe let's do a comment over here. So we know that x plus y is equal to 60,000 is the first line. And we know that y, okay, my dog wants to be petted here. Chachki, I'm busy. I'm working right now. Sorry. And then y has to be equal to 9,000. And then we know from here, I'm looking at this line right over here. And then from looking at this line right over here, I know that I have the line x is equal to 2y, okay, or y is equal to 1/2 x. Y is equal to, or y is equal to 1/2 x. And this is really the same thing as y is equal to 60,000 minus x. Is the first line, y is equal to 9,000 is the second line. And then if x is equal to 2y, we're going to have y, divide both sides by 2. Y is equal to 1/2 x. Y is equal to 1/2 x is the third line. Okay. And then, of course, everything is greater than or equal to 0. Okay, so let's plot these. Plot 60,000. You know, why isn't that bold? Hold on 1 second. Let me change something here. There we go. There we go, much nicer. 60,000. Now, by the way, I didn't type a comma here. Mathematica included this comma for me because of how I formatted my copy of the software. Let me make this very clear. I did not type this comma, That comma was automatically included by Mathematica for me because of my individual settings for the software. If you don't see the comma there, then don't worry about it, for God's sakes, okay? So I don't need to put down y here. So 60,000 minus x, okay? And then I simply have the line y is equal to 9,000, and then 1/2 x, okay? And x is going to go from, let's say, 0 to 60,000. $60,000 is our maximum. And plot range. Plot range is going to be, well, in the x direction, 0 to 60,000. And then in the y direction, 0 to 60,000. Okay. Oop. And then the plot style is going to be, let's see, the plot style is going to be, I think I want my first line to be thick and black, and the second line can be, well, let's make it, well, okay, we can go with black. And the second line, let's make it thick and red. And the third line, let's make it nice and thick and blue. Okay. And you know, let's make this picture a little bit bigger. How about 450 pixels? Let's make it 650 pixels. Okay. Okay, so these are the lines in question. These are the lines in question. I could make the ticks, these are the ticks, the numbers along the x and y axes. Those are the ticks. So what I could do, I could make them a little bit bigger. Font size is equal to 18. And font color black. Okay, now you can see them a little bit better. Okay, so now we want to do the region plot. We want to do the region plot and superimpose the region plot onto the plot of the lines. Okay, so I'm going to do my region plot over here, region plot, and that's going to look like this. Now this is where I need to use my y's. Okay, so let's see. X is greater than or equal to 0. Okay, we know that. And, well, actually, so if the mutual funds has to be greater than or equal, this is Y, mutual funds is Y. This has to be greater than or equal to 9,000, and the CDs has to be greater than or equal to 2 times 9,000. So actually, this is going to be 18,000, and y is greater than or equal to 9,000. And x plus y has to be less than or equal to 60,000. The double ampersand means and. Okay, so x is greater than or equal to 18,000. This should be a double ampersand. And y is greater than or equal to 9,000, and x plus y is greater than or equal to 60,000. And let's see, x has to be greater than or equal to 2 times y. X goes from 0 to 60,000. y goes from 0 to 60,000. Plot style is, let's say, yellow. Now I'm combining these pictures, which means everything has to be embedded inside the show command. Okay, why is that not... Okay, that should work. That's very unusual. So let me put the, you know what, this may have to come first. So Command X, okay, cut. Let's see, Command V, we're gonna do a paste. Put a comma there. The only problem with putting this first, well, let's see what happens. Okay. The tick marks, the plot may not look exactly the same, but let's see what we got. Okay, that's not at all what I want. Okay, hold on 1 second. That is not right. Less than 60,000 and x is greater than or equal to 2y. Okay, hold on 1 second. We are having technical difficulties here. So, okay, hold on 1 second. So this, let me do this plot by itself and see what I get. Hold on 1 second. Okay, something is very, very strange here. So x is greater than or equal to 18,000 and y is greater than or equal to 9,000 and x plus y is less than or equal to 60,000 and x is greater than or equal to 2y. X goes from 0 to 60,000, y goes from 0 to 60,000. This is exactly what I have. Yeah, okay, I had to pause my video and I was just playing with the RegionPlot command for a while and it's not giving me quite the results I wanted or expected, but that's okay. So everything looks okay so far. I clicked on the graph and I'm going to right click or control click on a Mac. Let's see, get coordinates. Okay, so I have coordinates here, let's say, let's say about 39,882. I'm actually going to write that down on a piece of paper so that I don't forget. Okay, so I'm looking for points to test feasibility, basically, okay? So it looks like in that picture, x is equal to about 39,882 and y is equal to about 15,441. Okay, so let's actually do a test and see if that point satisfies my conditions. Okay, so let's say that x is equal to, okay, what was that now? 39,882. 39,882, and y is equal to 15,441. 15,441. Okay, so we look at our restrictions, x plus y, is it really less than or equal to 60,000? That's true. Is x greater than or equal to 0? That's true. Is y greater than or equal to 0? That's true. Is x greater than or equal to 2 times y? That's true. Is y greater than or equal to 9,000? That's true. So it looks as if this is my region. Now, for some reason, I don't know why Mathematica did not plot it. That's very strange, but we have the lines and we know what our corner points are, so I'm not going to worry about that right now. So these are the corner points right over here. These are the corner points right over here. Okay, those are the corner points. So I simply have to figure out what are these corner points. Well, I have 3 lines. Okay, I have 3 different lines. Line 1 is equal to, okay, those are my corner points, right? So line, let me erase, well, I'll leave them for a moment. So line 1 is equal to 60,000 minus x. Line 2 is equal to 9,000. Line 3 is equal to 1/2 of x. 1/2 times x. Okay, notice, by the way, that I'm using lowercase x, not uppercase x. That's really important, okay? There is a difference in Mathematica. All right, so again, I'm looking for these corner points, right? So let me just erase that. There we go, okay. So solve. Line 1 is equal to line 2. What is x? Okay, so we have 51,000. Okay, and what is the y value going to be? Line 1, when x is replaced with x1, that's going to be 9,000. Okay, and then if line 1 is equal to line 3, what is x? X is 40,000. Okay, so then we're going to have, we need to know x2 is equal to 40,000. Okay, and again, we should have 9,000, but we can check. Line 1 or line 3, it's not going to make a difference. X is replaced with x2. Let me make sure of something. So what if line 1, x is replaced with x2? Yeah, it should be, okay, so then it's going to be the same thing. Right, so we'll have, sorry, it won't be 9,000, it'll be 20,000. And then we have line 1 is equal to line 2, and line 2 is equal to line 3. Line 2 is equal to line 3. What is x? 18,000. And so x3 is 18,000. And y3 is equal to, let's say, line 2 when x, it doesn't matter if we use line 2 or line 3, 9,000. So the corner points, corner point 1 is equal to x1, y1. Corner point 2 is equal to x2, y2. And then corner point 3 is equal to x3, y3. Okay. So which one of these gives us the best return? Well, let's see. Profit xy is equal to 0.07 times x plus 0.06 times y. So profit corner point 1 is $4,110. Profit corner point 2 is about $4,000. And then profit corner point 3 is $1,800. So the best profit, the most profit is going to come, the best return is going to come from the first corner point, because that gives me a return of $4,110, which is better than $4,000, which is better than $1,800. Okay, so to maximize income, okay, corner point 1, to maximize income, the investor should place $51,000 in CDs and $9,000. So $51,000 in CDs and $9,000 in the mutual fund. And the maximum return is going to be $4,110. Okay, so that was kind of labor intensive. The only thing that was kind of weird about this problem, for some reason, Mathematica did not do the region plot for me, which is a little strange. I may have made some kind of mistake with that when I entered, the region plot. That's a little weird. That is a little bit weird, but that's okay. We were able to figure out that this is the region plot right over here. So the region plot is actually, this area right over here. That's the region plot, right? And then, my corner points, I had, I had 3 corner points, 1, 2, and 3. 3 corner points. And you simply have to find your corner points. You have to find your corner points by determining the intersections of those lines. And then using your objective function, you have to figure out which corner point is going to bring you the maximum return on your investment. So it is, each individual step is not that complicated, but it's a lot of steps. It's a lot of steps to follow. So, you have to just be very careful when you do these problems, okay? I think that's it for now. I think this video has gotten long enough and we spent enough time on this. Hopefully, I hope that you found this somewhat helpful, okay? Let me just erase that. And that's going to be it for now. Okay, hopefully this was helpful to you. And if you need some help, email me and we can try to arrange a video conference. Okay, take care and good luck with your homework.